So this next talk is about integrating security into DevOps. I'm Leif Dreisler. I've spent the last couple years at a company called Redspin doing application security. So I was the application pen tester that you would hire. I'd spend a week or two assessing your application. I'd write up a report, recommendations, work with you. I did a little bit of developer training. So basically anything that I could do to make our clients more prepared to defend against cybersecurity threats, things of that nature, that would kind of fall under the scope of work that I could potentially help out with. I also did some HIPAA security risk assessments, some work with banks, and some other stuff, but my focus was definitely AppSec. I recently moved over to a company called BugCrowd, where I'm serving as a security engineer. So according to a 2014 report from Cisco, there's a shortage of over 1 million security professionals. That's something that probably a lot of you have already heard already, and if you haven't heard it, it's not that big of a surprise considering how many people are hiring security professionals, getting breached, things like that. So BugCrowd can help you fill that void in your organization by allowing you to leverage our crowd of researchers to act as an extension of your internal security team. So that's pretty vague. What do we actually do? We allow you to incorporate up to 15,000 researchers as part of a public or private engagement. So those can take a couple different forms, one of which is a crowdsourced pen test, where you're basically replacing me with 10, 25, 50, 100,000 researchers. And then we can also help you run a bug bounty program. So if you're unfamiliar, bug bounty programs create a symbiotic relationship between independent researchers and companies. It allows researchers to identify security vulnerabilities in a space where they know that they won't be prosecuted and they can hopefully get a reward. Companies benefit because if somebody who's willing to do the right thing and disclose a problem to you responsibly can beat a malicious actor to that same vulnerability, you have a much better chance of fixing it before somebody actually exploits it. So it's a win-win for both groups. The first bug bounty program was actually created 20 years ago by Netscape. So leader in the field back in the day, no longer around. Now hundreds of companies are running bug bounty programs with a huge jump in the last 5 years. This is the typical marketing slide of some of the companies that we've helped run bug bounty programs, so pick your favorite logo. So what are we going to cover? We're going to do a brief introduction to DevOps. We're going to talk about how to incorporate security into the DevOps process, and then how you can accelerate your return on security investment. So how did we get to the point of talking about DevOpsSec? It's coming from a need to adapt. Previously, companies had a single corporate network, and from security perspective, you just built a big fence around it. Applications were hosted internally on your own hardware, and if you saw somebody trying to climb over, break through, tunnel under, you knew that they were probably a bad actor, and you could just try and remove them from the network at that point. This model was reasonable at the time, but it doesn't really work out anymore. Now, with the proliferation of cloud computing, mobile devices, software as a service, your data is everywhere. With the introduction of agile development and distributed architectures, things are becoming more complex faster than ever before. Development sprints have dropped to 2 weeks. The idea of a version is almost completely gone. Production code changes are happening all the time, and as something comes up as a problem, somebody might be writing a fix for it that's getting deployed within the hour. You used to buy Microsoft Office 2007, 2010, 2013, but now you just buy Office 365. You don't really know when changes are happening. Sometimes that's good, sometimes it's bad, but everybody's running the same code base. New features are getting pushed out continuously. It's not possible to build a big fence around your data because your data is all over the place. You can't build a fence that includes your corporate network, a little bit of Google, a little bit of Microsoft, a little bit of Dropbox. You can't do that. So you got to come up with a new fence. And we've seen something similar happen with dev and ops. Bringing dev and ops together to manage configuration and infrastructure as close to developers as possible, creating a feedback loop and reducing the possibility of failure. This gave birth to DevOps. So devs care mostly about innovation, creating new features, building new applications, and are generally pressured by sales or marketing to meet deadlines. As a result of this, sometimes security or performance might suffer. On the other hand, your ops team is worried about maintaining stability. They don't want sites going down. They don't want servers going down. They want to make sure that customers are happy and that everything's stable. This can sometimes get translated into don't change anything. So those groups originally might have had some opposition. But with the creation of DevOps, that's core to the agile development methodology, which is something that's been widely adopted across the industry. It allows you to deploy code quickly or even continuously, increase the speed of release cycles, and reduce the time to fix bugs. As things are getting pushed to production more quickly, a bug might be introduced, but you know that you don't have to backpedal very far to go back, create a fix, and then push the fix out just as quickly as the problem was created. This reduces the tension between stability and new features. Because stability can be corrected much quicker, you can push out new features quickly at the same time. But this is also kind of a double-edged sword because the emphasis on rapid change means that code's getting pushed out quickly. It means that there isn't as much time for security testing, so that there's a higher likelihood that if there is a problem, it's going to just get pushed out to production as the code goes live. So how do we fix this? We need to bring in a third team, security. So similar to moving dev and ops closer together to provide increased stability and decreased deployment time, now we want to move security closer to the code base to provide increased protection to code and data. You want to identify problems in the code and configurations as quickly as possible and relay this information back to the development and ops teams so that they can fix problems. So that sounds great, but it can be kind of difficult to navigate. All three of these teams are identified in different ways. This can cause them to act as adversaries, which isn't good for business or cohesion within your organization. Dev wants to build things, op wants to maintain stability, and security wants to break things and point out problems. And as somebody who used to do that, it's pretty fun, so I can see why the security team would act that way. So these three aren't going to fit perfectly together. But what are some ways that we can integrate security into DevOps? The secret is start simple, take small steps, and leverage easy wins. If you try and do everything at once, it's going to fail. The first step is getting developers to care about security of every line of code that they write. You need to have a dev team that cares about code, because the developer's job isn't just to write code. It's to write reliable software that works well and is secure. So how do you do that? You need to educate developers about the security implications of their code. External and internal developer training is both great, and I think that both are part of a secure software development life cycle. External developer training means bringing somebody in, scheduling time on the calendar, have them talk about the OWASP top 10, maybe show you how to identify some security vulnerabilities, talk about how bad SQL injection is, things like that. I think internal developer training is just as important, if not more important, on a daily basis. And what I mean by internal training is you could potentially schedule impromptu workshops, but the main thing is, as a security issue comes up, having the security team talk with the developers about how the issue is identified, what's the impact, and talk about remediation strategies. So don't just say, we found some cross-site scripting, make sure that you're using the filtering gem from Ruby to go through and check that. Nobody really cares when you just tell them what to do. It's definitely more important to talk about how you identified it, what's the problem, and then talk about how to fix it as a team. And part of that goes into building a successful product. Part of that is making sure that the product is everybody's baby, not just developers. Each team might be incentivized in slightly different ways. Like I said, dev wants to build things, op wants to maintain stability, and security wants to break things. But you need to care about all three. Even if you care about one more than the others, that's fine, but all three of them should be in your mind. So how do you make everybody take ownership over the product? You want to bring everybody into the same team. Even if you're on dev and ops, you can still work together as part of the same Scrum team. You can also build what we call at BugCrowd and a lot of other places a firefighting team. So on a rolling schedule, you're going to have a mixture of different team members that are working together to solve problems. These might be reports of a site going down, it could be a usability problem, it could be an ongoing security threat. It's something that dev, ops, or security would have to deal with, but it's going to come to the firefighting team first. They're going to see, can we fix it on our own? Is it something that we can just deal with and nobody else has to get bothered? Or is it a larger problem where we actually need to build it into the development roadmap? We need to contact the ops team. They need to reset some settings on Nginx. They need to upgrade to a newer version. So DevOpsSec is going to get bundled into a single firefighting team, and they're going to make those initial calls for you. Decreasing the friction between teams is going to cause them to work better as a whole. Seeing how other teams deal with problems from a security perspective or a dev perspective or an ops perspective is going to make you more likely to go and ask for help from another team. If the teams don't interact, it's almost as if the other teams don't exist. Each team brings something great to the table that the other teams can benefit from. So what makes the security process so hard to manage? A lot of it is because as a company grows, they want to increase the number of developers so they can push out new features of the product, which makes their clients happy. A lot of times the security team doesn't grow at the same scale that the development team does, and they have a bunch of other responsibilities. They need to make sure people aren't getting phished, which is pretty much impossible. You need to monitor server architecture changes, run scans, talk to vendors, respond to ongoing security threats, and they might need to be reviewing code before it goes out. So what can we do to make their lives easier? Similar to the QA process, you want to have automation and manual testing as part of the build process from a security perspective. That means talking about security starting with peer code reviews. When you're pushing code to GitHub or whatever version control, talk about the security implications of the code as well. So this goes back to having developers that are trained in security. You also want to have test-driven development applied to security. So you're mostly used to having unit tests that are dealing with usability, making sure that you're not having regression of features, things like that. You can also put basic tests in for things like cross-site scripting, SQL injection, making sure that your CSRF tokens are working correctly. There's a lot of automated things that scanners can check for that you can build in as checks into your test-driven development as well. You can also leverage open source or commercial tools for dynamic or static security analysis, doing things like Brakeman for Ruby to check for static security vulnerabilities, or having somebody run Burp Suite or Zap or something like, or Sentinel to run against dynamic tools. Testing creates a great precedent for quality and stability, and building security into this process creates the same precedent for minimizing vulnerabilities. Another thing that you can do is you can build in an application layer IDS. An app layer IDS can give your firefighting team training and provide a heads up against malicious actors. This means building proactive security controls into your code base. So things like server-side validation when the client fails. You should have server-side validation anyways to make sure that somebody isn't sneaking a script alert one into a username. But how many of you are checking to make sure that, okay, the username isn't allowing a less than sign, but for some reason the server-side check is the one that caught it? That means that somebody's probably manipulating a post request somewhere, which means they're probably doing something that's outside of what a normal user would be doing, so you can target them as a potentially malicious actor. The same thing goes with hidden fields, radio buttons, or drop-down menus. If you're expecting California, New York, or Arkansas as an answer, and you're getting -- wait for delay 10 seconds, I mean, it's pretty clear that they didn't use the drop-down. That's something that somebody had to manipulate in between. It's not something that your parents are using the computer and somehow getting a wait for delay in there when they're trying to pick Alabama. You can also check for blatant SQL injection or cross-site scripting. That kind of goes along with the other fields I talked about, but could be applied to anything. You can also set up some URIs that exist but aren't linked with anywhere in your application and run them against a list like Dirbuster, which is an OAuth tool that brute forces directory names. So you can just pick a bunch of those directory names from that list, set them up as URIs, and then flag any traffic that's browsing to those because you know it's not a normal user because it's not linked anywhere in your application. So something like /admin is kind of borderline as far as, that might be somebody who's just messing around and wants to see if it exists. But as you get more specific with things to your architecture, you can kind of be sure that it's somebody who's probably trying to do something that's not so great. Another way to help out your internal security team is to introduce crowdsourcing. This helps level the playing field between that discrepancy of 500 developers and 5 security professionals. You want to offer a reward to freelance researchers if they're the first to find an issue, and that's a great way to include some sort of automation because automation doesn't replace having people look at your code. Scanners can really only go so far. They're going to be great at finding things like reflected XSS, SSL problems, managing version numbers for libraries that you might be using or gems or something like that. But they're really bad at finding things like privilege escalation, privilege traversal, advanced attack vectors that require placing some file somewhere in like an upload field and then referencing it later. multi-part attacks like that, scanners just aren't very good at finding. So you still need people looking at your code. And now with crowdsourcing, it's cost-effective to utilize people at scale. Compare this to me at my last company working 40 or 80 hours on an engagement. If you hire 25 or 50 researchers that can each spend 4 or 5 hours, that's way more time than I could ever spend in 2 weeks. And this can help augment your internal security team because it frees them up from reviewing this code and making sure that there's no security problems to only reviewing submissions by other people that have spent time doing this. This will free your internal security team up to do more fun projects, or maybe you just don't have to hire new people on as quickly. Both of those are great for your business because it either saves you money or it allows them to accomplish projects that they wouldn't have normally had time for. So you can push out your code in a development instance before it goes live. Just assume that your code's broken, let a crowd of researchers take a look at it for a day, 2 days, a week, and then push that code to production. You can always have whatever your pre-release candidate is out there for people to look at and put on your website.com/security. Hey, please look at our development instance, submit any vulnerabilities responsibly, and we'll pay you money. This also trains your fire team to respond appropriately and involve other teams as necessary to fix bugs. As you have bugs coming in from the external channels, this will let them try and deal with them first and involve other teams as necessary. The other problem with doing a single pen test during a year is you just don't really get enough bugs. If you get one pen test done a year, you might get 5 or 10 bugs. People really aren't going to care about it that much the rest of the year. We have a client in Structure that has a program, a application called Canvas, which is an open source learning management system. They got way more bugs than they had ever gotten by using a crowdsourced model. And why is that good? Because lots of bugs is the best way to train your development team. It goes back to that education, that closed feedback loop of making sure that developers understand security, care about security, and are constantly being reminded of the implications of their code. Integrating this into your alpha process will allow you to close that feedback loop quicker and get problems back to dev and back to ops as security issues come up. You can also start to do some analytics on your own data. Are we really bad at cross-site scripting, or are we really bad at protecting our admin page? You can look for systemic problems in a vulnerability type or in an area within your application that can allow you to either give those teams more training or move a more senior team to areas that are more sensitive. So you can kind of use this as a way to protect the most sensitive areas of your application. So one of the things that's the best about crowdsourcing is it changes the model from one based on effort to one based on results. When you're rewarding people for only finding valid submissions, you're not paying for the time that they spent not finding anything. After a couple years of using the same pen test vendor, which you should be switching anyways, they are going to get lazy. As somebody who used to do pen tests, if it's something that you know you're going to have to come up and do again the next quarter, you might not be as motivated to find something if you know you're going to have to find something next quarter to keep the report looking fresh. This will help you reduce your internal security team load by augmenting some of that onto the external parties. So, in summary, small steps means easy wins. That means introduce changes slowly and security concepts to your development team gradually. This helps developers care about the code, have feedback in place between security and developers to make sure that devs understand the impact, the identification process, and remediation. Don't just say, fix this. Security is a process, not a product. So a lot of vendors out there are trying to sell products, but what you really want to do is you want to fix the security process. There are products that can help with that. So like I said, scanners are good at identifying certain types of vulnerabilities. You can use other things to keep track of making sure all of your libraries stay up to date. But it is really something that you need to build from the ground up. There's not a single way to do this right. There's not a step-by-step instructions that are going to guarantee success from a security perspective, but making sure that everybody that's part of the product development team and the ops team cares about security is a great place to start. Don't wait for a fire to hire your firefighters. Make sure that your firefighting team is getting trained over time with small fires so that if an inferno really does happen, they at least have some training and you're not just organizing a group of people to deal with something. You already have a firefighting team in place. Let them handle it. Let them ask for help as needed. And then the last point is crowdsourcing can augment your internal security team. So integrate crowdsourced security as part of your development life cycle and get feedback on the pre-release candidates to make sure that there's no bugs before you push things to production. So there's questions, and we're hiring, so if some of this stuff sounded cool, come up and talk to me or Jennifer later, and there might be an opportunity for you at BugCrowd. So questions?
Why do you think it's so hard to convince many companies to do secure code reviews?
Why do you think it's so hard to get companies to do what type of code reviews?
Secure code reviews.
Honestly, as somebody who came from a computer science background, I think a lot of developers just don't really get a lot of security training. I mean, I certainly didn't get any in college. A lot of my friends went off to become developers for big companies and started writing code for production. Within a couple months, they didn't really get any security training. And as you keep moving through that process and not getting any more security training, you keep becoming more senior and still not really caring about it. So why would you make the push to have security part of your code reviews when it wasn't something that was ever made important to you as you rose to the position that you're in?
It's kind of interesting that pen testing gets that attention, but secure code reviews are very underestimated.
Yeah, and I think that's where it needs to start. I mean, pen testing is great. It's going to identify some problems once or twice a year, but what about all the other days of the year where your code is just out there before it gets reviewed? You want to have developers being the ones who are kind of the flagship part of the security process, because they're the ones that are actually going to introduce vulns. I mean, it's not their fault. Everybody makes mistakes. It might be due to a lack of education or just an error, but they're the ones who are actually writing the code. They need to care about security just as much as the security team.
Statement and a question. The PCI specification requires secure code review, requires secure code training, requires that DevOps is trained in secure code review, and for the assessor to verify that all of those processes are in place. Now the BugCrowd, is any entities, any businesses using BugCrowd to perform their PCI required application pen testing, and are those results being accepted by any QSAs?
So, yeah. So the question was, are we using BugCrowd? Is BugCrowd able to be used as part of the PCI process, and are they accepted as a vendor for a QSA? So I'm actually not sure. I don't know enough of the different instances where people have used BugCrowd. I know that a lot of people are using BugCrowd as a way to identify security problems before an audit. So you'll run a program with BugCrowd a month or two before your PCI pen test, have us pick up a bunch of the issues, you guys fix the issues, and then there should really be no surprises by the time that it gets to your audit. I know the last company that I was at, Redspin, people would use our pen test as part of PCI compliance, even though we weren't a QSA.
Right, no, you don't have to be,
So I'm,
to be a pen tester.
Yeah.
QSA has to say, yeah, you have credibility as a pen tester.
Yeah, so I don't actually know if that would work or not. I would imagine that it would,
Sounds like it did.
but because I did that and we weren't a QSA at the last company, so I'm not exactly sure. That's something that it's a pretty good question. We could maybe involve somebody from our operations team that would be able to answer that if you want to give me a card or an email or something like that.
Okay, last question.
Can you please clarify, I'm just a little bit confused, the developers who are actually the crowd who are doing the tests, are these engineers at BugCrowd itself, or is it developers that you qualify somewhere else?
Yeah, so our crowd is all over the world. We have people in the United States, people in Europe, people in India. Anywhere there's somebody as a security researcher, they can sign up and join the crowd.
Is there a qualifier you use?
No, so we don't have any qualifications to entry, but we do have a gamified system where as you submit vulnerabilities, if you're submitting a bunch of things that are invalid, your rank is going to get lowered. Whereas if you submit vulnerabilities that are good, your rank's going to go up. So if you don't have any rank or you have a negative rank, you're not going to get invited to private programs. You're only going to be able to submit bugs for public programs. So there is an incentive for people to perform well and submit valid vulnerabilities, because that's the way that you get invited to the more lucrative private programs.
And multiple people find the same bugs?
Yeah, so if multiple people find the same vulnerability, only the first one gets paid out. So you do get a little bit of positive rep for finding a duplicate, because yes, you did identify a valid security vulnerability, but you only get paid if you're the first one.
It's like Uber for code review.
Yeah, something like that.
Okay, thank you very much.